This is Anand Saran Sahu welcoming everybody to MKD Education. Well, we have discussed all the questions, means 6 number of questions for chapter 2. Now this session is about the question discussion of rest questions. We have planned 12 questions for equilibrium chapter and 6 questions already discussed in last class. In this class we will discuss from question number 7 to question number 12. So for better understanding, you should refer only MKD Education, right? MKD Education. Don't forget MKD Education. So now question number 7. So now we start question number 7. A roller weighing 3 kN and lying on a smooth inclined plane of inclination 60 degree. Smooth plane means there is no friction. Inclination 60 degree. So you can see here the angle of inclination is 60 degree to the horizontal. Is prevented from rolling down the inclined plane by a string as shown in the figure. So this is the string. This is the string AB. Find the tension in the string AB and reaction at C. So C is the point of support where we have to find the reaction, that is RC. You can see here RC is marked here. So now you see this 3 kN is nothing but the weight of the roller, and TBA, which is the tension in the string AB. So it is acting from B towards A, that's why TBA, and RC is the reaction at point of support C. So we will have 3 forces. This is RC, TBA, and of course 3 kN the weight. And the angle is, this is 60 degree. So if this is 60 degree and this will be obviously 60 degree. So this weight with RC is 60 degree, and see this is 30 degree. This angle is 30 degree. So this will be 60. So 60 and this is 60 again. So TBA and 3 kN के बीच में हो गया angle 120. Total is 120. This is 60. This angle is 60. This angle is also 60 because this is 30 degree. And again this is 90 degree. If this is 30, this is also 30, this angle is 30, so 90 plus 30, 90 degree plus this is 30 degree, so total हो गया 120. मतलब 120, 120, 240 गया, rest is 120. So now we can put Lami's theorem because the system is in equilibrium. So start from RC, this is RC divided by sine of opposite angle is 120. So all the angles are same, so RC, here RC equal to TBA equal to 3 because all sine 120 can be cancelled. So RC equal to TBA equal to 3. Right? Now come to question number 8. So two cylinders A and B of diameter 100 mm and 50 mm respectively are placed in a trough as shown in figure. Weight of A, roller A is 200 Newton. This weight is 200 Newton and that of B is 50 Newton. This is 50 Newton. So neglecting friction, find the reaction at the contact surface. So here the contact surfaces are, this is point A, here R1, मतलब first contact surface of B with the wall. Here is another contact surface R3. So this is R1, R3, and this is the point of support B. मतलब first roller is providing reaction with second, मतलब cylinder 2 or roller 2 on A and A on B in return. So these two reactions are equal and opposite, and of course the weight, this is the weight and this is also another weight. And here you can see the roller A is finding support at this point. So let this reaction is R2. So we have the reactions R1, R2, R3. Here it is R4. So now come to the free body diagram. Here free body diagram. If you consider body B and body A, we will have minimum number of forces in body B because here R1 and this is R4, this is R4, this is R1, another force is weight, that is 50 Newton. So 3 forces are there, out of which 50 Newton is known, so we can easily find R1 and R4 by using Lami's theorem. So R4 divided by this angle is sin 90 because see R1 is horizontal and R1 is horizontal, weight is vertical, so angle is 90 degrees. So R4 by sin 90 equal to R1. R1 is the horizontal force. This is 36.8. 36.8. So now this angle is 180 minus 36.8, that is 143.14. So R4 by sin 90 equal to R1 by sin 143.14 equal to 50. So the remaining angle 126.86. 50 by sin 126.86. So now we get R4 equal to 60.2.49 and R1 equal to 37.48. Now come to roller A. So here there are four forces. Four forces means one is the R2, force R2 acting like this. W, which is 200 Newton acting vertically downward. This R3 force, R3 reaction, it is acting horizontally. And of course the R4 force, R4 reaction. So we have four forces, we can't apply Lami's theorem, that's why we have to use the condition for equilibrium, that is total force along x direction 0, total force along y direction 0. Now total forces along x direction. So R2 is resolved for its two components. One is along positive x, R2 cos 45 और sin 45, क्योंकि 45 तो दोनों सेम है. So R2 sin 45 this will be R2 cos 45, दोनों सेम होगा. So R2 x direction में R2 sin 45 और RA का जो component आएगा RA cos, if this is 36.86, this is R4. So R4 sin 36.86 आएगा horizontal direction में. So R4 sin 36.86 plus हो गया. And this is R3 which is towards negative x, that's why minus हो गया. So R2 sin 45 minus R3 plus R4 sin 36.86 equal to 0, इक्वेशन 1 हो गया. और टोटल y मतलब R2 का cos 45, R2 cos 45, फिर R4 का जो cos है cos 36.86 वो नेगेटिव में है, नेगेटिव y डायरेक्शन में, इसलिए नेगेटिव. And of course 200 Newton is the weight, so 200 minus 200 equal to 0. So now if we solve these two equations, we can find R2 equal to 353.55 Newton and R3 equal to 287.48 Newton, right? So now come to question number 9. So here two equal heavy spheres of 50 mm ready, because two radius are there, are in equilibrium within a smooth cup. This is not cap, this is cup. Smooth cup of 150 mm radius. So the radius of the cup is 150 mm, मतलब this distance 150 mm. So that the reaction between the cup of one sphere is double than that between the two spheres. Means the reaction between cup, this is the cup, this is the cup or bowl you can say, in which the two spheres are held in equilibrium position. So a reaction will come definitely here. So this reaction between one sphere and the cup is double than between the two spheres. So obviously there are two spheres having contact with each other, so each sphere will provide reaction over each other. So this reaction and this reaction, if you compare, this reaction will be double than this. So now come to this part, you can get clear. So let this is a D point, so that this is RD. RD is the reaction at this point D. मतलब ये है reaction between cup and one sphere RD, and the W means weight of the this sphere. W, it is not known, it is not required also. Simply you just take W, and we have to show that this is another the reaction RC. मतलब B is providing on A, that is RC. It is important that we should take the reaction, मतलब B जो force A के ऊपर अप्लाई करेगा वही रिएक्शन हम लेंगे, मतलब this is acting along negative x. So if you take B body, then we will take the right towards right, that cylinder A or roller A puts on B. Now we will take only three forces. Now RC means this body acts upon A and RD. This is the reaction of cup and sphere, RD and weight. So you know this total is 150 minus 50 is the radius of the ball, so the remaining is 100. This is 100. So 50 radius, again 50 radius. So now it becomes a on equilateral triangle 100, 100 and 100. So each angle is 60 degree. Each angle is 60 degree now. Okay. So now see, RC is horizontal, W is vertical. So this angle is 90 degree and this angle is 60 degree. मतलब 90 plus 60 150 and of course 90 plus 150 हो गया 240. So rest 120 up from 360 degree minus होगा. So now apply Lami's theorem. RC divided by opposite angle sin 150 equal to RD force divided by 90 sin 90. So RD by sin 90 equal to W divided by this angle sin 120. So after calculation we get definitely RD equal to 2RC. This ensures that reaction between curve and one sphere is double than the reaction between the two spheres. So come to the next question. So now come to question number 10. A spherical ball of weight 100 kg force is the unit of force, rests on two smooth inclined planes whose sides are inclined at 30 degree and 60 degree to the horizontal. So we have to find the reaction of each inclined plane on the ball. So this is the spherical ball. This ball and the weight of the ball is 100 kg force. So this is held in equilibrium under two inclined planes. So one of the angle of inclination is 30 degree, other plane का inclination है 60 degree. We have to find the reaction provided here, that is RA, and if this point is B, this will be RB. So now I am erasing all the marks so that you will get cleared, right? So again we will use this. The Lami's theorem we will use to solve this problem, because only there are three forces. One is 100 kg force which is acting downward, because irrespective of the position the weight is always acting downward, 100 kg force. Only the reactions RA we have to find and RB. So three forces are there, we can easily use Lami's theorem. So Lami's theorem use करेंगे. ये 30 डिग्री है तो ये कितना होगा 60 डिग्री होगा. Similarly if this is 60 degree, this will be 30 degree. मतलब RB with horizontal 30. So if you draw a horizontal line here, RB with horizontal, this is 30 degree. So this is 90 degree. Total हो गया कितना 120. Similarly this is 60 degree. Already I have told you RA के साथ 60 degree horizontal के साथ. So total ये 60 और ये 90, total हो गया 150. So 120 50 के बाद 340 से now remain 90. So you use Lami's theorem. Already you know what is Lami's theorem. So RA by sin 120, RB by sin 150 equal to 100 by sin 90. So that you get RA का value 86.6 and RB का value 50. So now come to the next question, number 11. A light string ABCDE whose extremity A is fixed has weights W1 and W2 attached to it at B and C. So B में W1 and C में W2. It passes round a smooth peg at D carrying a weight 300 Newton. So the weight of this weight is 300 Newton. E में जो है at the P and E as shown in the figure. If in equilibrium position BC is horizontal, so this BC is in horizontal position and AB and CD make 150 degree. This angle is 150 degree and this angle is 120 degree with BC. BC means horizontal. Find tension in the portion AB. So this point is A. So AB portion, then BC portion, then CD portion, and magnitudes of this W1 and W2. So you know here the tension in this portion, matlab CD, is nothing but equal to the weight here or the load here. That is equal to how much? E point में कितना load है? Already there weight of 300 Newton attached at free end. So मतलब ये जो tension in portion CD becomes equal with this 300 Newton, right? Now come to this part at Lami's theorem. Put Lami's theorem at point C, because we have three forces, that is tension in the portion BC which is horizontal. You can write TCB because from C towards B, and 300 Newton already there. It is make in this position, and W2 you know W2 is acting downward, so this angle is 120 given, so this angle is 120. So if you make a horizontal line here, this will be 60 degree, so 90 plus 60, this is 90 degree plus 60 हो गया total 150 and TCB. So now you use Lami's theorem, TCB by total sin 150 equal to W2 divided by sin 120 equal to 300 by sin 90, so that you get TCB equal to 150 Newton and W2 equal to 259.8 Newton. So now you see this TCB is important because we have to use this TCB again while applying Lami's theorem at point B. So if you put Lami's theorem at point B, we have again tension in this portion, that is TBA, and W1 is the weight and tension in the portion BC, so TBC, which is already we have found 150 Newton. This is. So now again apply Lami's theorem, so that W1 equal to opposite angle sin 150 equal to TBA by sin 90 equal to 150 by opposite angle 120. So that you get W equal to 86.6 and TBA equal to 173.2. So now come to the last question, that is question number 12. The cylinders shown in the figure have the same diameter, but the cylinder 1 weighs 180 Newton and cylinder 2 weighs 120 Newton. So we have to find the reaction at the supports. So this is cylinder 1, this is cylinder 1, this is cylinder 2. Cylinder 1 का weight है कितना 180 Newton and 2 का weight कितना 120 Newton. So this is 120 Newton. So we have to find the reaction at the contact surface. This is one contact point A, so that we get the reaction here RA. Here another contact point C, so we get RC here, RC, and this is C point, so this reaction is RC. The reaction which is providing by the body 1 over body 2 and body 2 over body 1. So this point of contact is B, so that this is the reaction RB. So A, B, C, D, obviously this point is D, so reaction this is RD, right? So now let's start. If you consider body 1 first, then body 1 में you have कितना forces है, RA 1 force, weight the second force, another force RC and another force RD. So चारों forces है, 4 forces are there, out of which 3 forces are unknown, which is very difficult to solve because it is the case of equilibrium case. So definitely we can't use Lami's theorem also. So definitely we will use, or we will start from body 2 where 3 forces are there. One is the weight, this weight, and reaction RB and reaction RC, which is provided by body 1 over 2. So this is RC, RB and the weight 120 Newton. Now see this angle is given 15 degree. So obviously this angle will be 75, right? This is 75. So now see 120 RB के साथ horizontal का कितना angle हो गया 75. So this angle is 75 degree. मतलब total हो गया 165. Similarly horizontal के साथ this is parallel to the plane. RC is parallel to the plane. So RC with horizontal is 15 degree angle, already given, mentioned. So total angle now become 90 plus 15, 105. So rest will be 90. So now apply Lami's theorem. So RC by opposite angle, RB by opposite angle, 120 by opposite angle, so that we get RC equal to 31.05 Newton and RB equal to 115.91 Newton. So again, so RC is important because RC का value again use होगा while considering body 1 or cylinder 1. So cylinder 1 में अभी RC का value मिल गया. So RC and 180 दोनों known values है. Now only unknown values are RD and RS. So by using here 4 forces we can't apply Lami's theorem. So we will use the condition of equilibrium, that is total x0, total x0, total y0. So if you apply total x0 in here, then you will have RD sin 15 towards the left, RC cos 15 again towards left, and RA is towards right. Similarly y में RD cos 15 upward है और RC sin 15 downward है and 180 already downward. So two equations will come. If you solve, you get Ra equal to 80.37 Newton, Rd equal to 194.6 Newton. Right? So पिला माने आमे 12 टा क्वेश्चन डिस्कशन कले चैप्टर 2 रो इक्विलिब्रियम चैप्टर रो आउ ये एथरे इंपोर्टेंट हला लामिस थ्योरम. You can see लामिस थ्योरम is applied everywhere. Any kind of equilibrium problem जदि 3 forces अछि, you can use लामिस थ्योरम. आउ जदि 3 रु अधिक अछि, then you will use conditions for equilibrium, that is total x0, total y0, total moment एटी दरकार नै, total forces along x direction 0, total forces along y direction 0. So you can use this formula to solve any kind of problems, right? So friends, please check the calculations if there might be some mistake, right? So okay, if you have any doubt, you know MKD का क्या है, WhatsApp number है, email address है, you can query, right? Thank you.